Hey everyone, Haley here. Today I'm going to walk you through the process of making ATP, starting from the glucose and carbon dioxide using our poster that we just spent pretty much the whole semester making here. Okay, so bear with me. I'm going to point and as we walk our way through the poster here. All right, so first things first, we're going to start up here with the pentose phosphate pathway right through here. This pathway begins with glucose, right up through here. And in this process, it's parallel to glycolysis. So it's going to generate some NADPH, which is right through here in this first process here. And that is going to be made into ATP. It also is going to produce a ribose 5-phosphate molecule, and this is used to synthesize PRPP, which we will talk about a little bit later. That is needed for the pyrimidine synthesis. So one of the final products for the pentose phosphate pathway is fructose 6-phosphate. So with this here, we are going to travel it down to glycolysis, which is what we will talk about next. Now, glycolysis is the production of the glucose to two pyruvate molecules. So during this, there is all these steps that occur. Two NADH molecules are produced right here. These molecules in glycolysis form 1.5 ATP per molecule, so total 3 ATP molecules are created. Also during glycolysis, we have the creation of 2 ATP down here, but we also use 2 ATP to form ADP up here. So they cancel each other out. So total in glycolysis, we will form 3 ATP molecules. Now, when oxygen is present, we are going to come down here from the pyruvate molecules to the pyruvate dehydrogenase complex. This here starts with pyruvate, and we are going to convert it to acetyl-CoA. So during this complex, 2 NADH molecules are produced right over here. And since it is mitochondrial NADH, they'll produce 2.5 ATP molecules through this. So total in this process, 5 ATP molecules are produced. We are then going to use that acetyl-CoA that is produced to drop down into the citric acid cycle, which is down here. During this process, it's a 9-step cycle here. We are going to produce the oxalacetate, and during this whole process, we're going to produce 20 ATP molecules. This happens in a combination of the conversion of FADH2 and NADH. They'll convert to ATP molecules, as well as 2 ATP molecules being produced, which you see right down here. Okay, so then once we do this, an FADH2 molecule and an NADH molecule are going to come over here to the electron transport train to help move those enzymes through there. Now, once we have all this ATP produced, we can come back to the top here and talk about this PRPP that is synthesized. So this molecule is one of the first steps needed. We travel all the way down here in the pyrimidine synthesis. So I'll back up a little bit. And everything we worked on here is all the production of the nucleotides and essential amino acids. So hope that was helpful to walk you guys through the production of ATP using our lovely poster here. And hope you guys had a good semester.